an empirical formula and the molecular formula has a relationship. An empirical formula shows the simplest whole number ratio of each atom present. The simplest. Some texts will say the smallest whole number ratio. And so, looking at the empirical formula, by definition, empirical formula shows the empirical formula shows the simplest whole number ratio. So the word you must underline is the simplest and the ratio. So it shows the simplest whole number ratio of each atom. So we can actually use the empirical formula to predict the composition of each element, their percentage composition of each element present in an unknown compound. If we have a certain organic compound, we can use the empirical means to determine or detect the percentage of each element present, because these elements they come together to form the compound. And because these elements are coming together to form compound from our basic chemistry, they have their ratio at which they interact to make up the bond. And so because this ratio must be determined in order to predict which amount of carbon, which amount of hydrogen, and which amount of oxygen is making up these compounds. So the empirical means becomes necessary. And so the empirical formula shows the simplest whole number ratio of each element present in the compound. While the molecular formula shows and so you can see the basic difference there. This has to do with the actual. This has to do with simplest. And so we can mathematically, by a way of calculation, to say that the molecular formula with this molecular formula N.F, the molecular formula can be equal to empirical formula multiplied by N, where N is the number of the atom, where N is the number of atoms. So we can also say that the empirical formula, also by way of relationship, to say that the molecular formula N.F divided by N will give us the empirical formula. So we can relate this to empirical and molecular formula. And then for chemists, those of you that have been finding it difficult to understand organic chemistry, you must first of all understand what we mean by organic chemistry. From there, you understand the origin of the chemistry, which is organic compounds. The word organic chemistry simply means organic compounds. This chemistry of organic compounds. And then, if you understand what are organic compounds, and we say organic compounds are compounds of carbon and its derivatives, meaning that compounds that deals with carbon majorly are organic compounds. We step a little further to tell you that organic compounds does not only comprise of carbon, but there are other elements such as hydrogen, oxygen, sulfur, phosphorus, nitrogen, metals such as potassium, sodium, lithium, magnesium, and so on. These also pair, they also interact with carbon to make up organic compounds. And I said that organic compound couldn't have been possible without the ability of carbon to interact with itself. So it was very important to understand that carbon has the ability to interact with itself to form long chain hydrocarbon. Listen, carbon has the ability to interact. It is not all elements that has the ability to form long chain hydrocarbon. The next element that has such ability to do same as carbon is silicon, which is the second member of group 4 after carbon. And so silicon form there, but silicon form what we describe as xylene and unstable compounds. But carbon form a more stable compound with itself called the alkanes. And so that ability of carbon to interact with itself, an element to element, same element interacting with it, with same element interacting with the same kind of element to form a long chain hydrocarbon, is what we describe, remember, as the word catenation. So organic compounds couldn't have been possible without this process of catenation. So catenation is like the bedrock of organic compounds. So compound like organic wouldn't have been existing without this. And that is why carbon becomes the unique compound in the unique element in organic compounds. Without carbon, that compound ceases to be called organic compounds. And carbon can only do that with catenation. And then, quickly, as a way of summary, we looked at the composition of organic compounds. And then, like I said, that led us to what we call the empirical analysis and molecular. So with the empirical analysis led us to what we describe as empirical formula and then molecular formula. And then we said that molecular formula and empirical formula has a relationship, and of course the similarities also, they also have differences. And so empirical formula simply deals with the simplest whole number ratio. The simplest whole number, meaning the smallest. The simplest whole number ratio of each atom. Some texts say each element present. So meaning that each of the elements empirically in the smaller form can be calculated, can be determined. And then molecular formula deals with the actual in totality, everything put together. Molecular formula deals with the exact, the actual whole number ratio, what it should be. That is what molecular formula deals with. And then we also say that mathematically they can also be related as this, that n dot f is equal to e dot f times n, as n is a number, is a whole number. We have e dot f will be equal to n dot f divided by the n, which is the whole number. You can see all of them having a whole number. And so, in our next video, we'll be looking at the mathematical expression that has to do with analytical and empirical determination. Solving some problems using empirical and molecular formula to see how we can actually determine their percentage composition in an unknown compound. So sit tight, don't go anywhere, click the subscription button, like and share as I see you in our next video. Thank you and God bless you.